Algebra 1, Chapter 6, Section 3. We're going to look at the third way to solve a system of equations, and that's the elimination method. Okay? How do you use it? That's our essential question. Well, let's kind of define it first. What is elimination? If you think of elimination, you're getting rid of something, and that's what we're going to do here. You're going to add. You want to be able to add your two equations together, down in the column like terms, in order to eliminate one of the variables. Okay? Here's a good example of right here. This is a simple example right here. They're not always this simple. A couple things you'll notice here. Okay? They're not in the y equals, so I wouldn't try to graph it, because if they were both in the y equals, it'd be easy to graph. Neither equation says y equals or x equals, so I'm not going to use substitution. They're both in standard form. Okay? So I want to use elimination. That's a good sign right there. When you see them lined up like this, or they're not in y equals, or it's not a substitution form, do elimination. This is the most popular way to do it right here. So what I'm going to do is I'm going to look down and see if I added them up, would I cancel an x or a y? And I would cancel the y right here. 2x plus 6x is 8x, plus 5y minus 5y is 0. So I cancel the y's out right there, and I get positive 8. So I got 8x equal to 8. I got one equation, one unknown. Solve for x. Divide it out. X is 1. Once I know x, now I take either equation. It doesn't matter. I just took the first one. Plug your 1 in for x, and then solve for y. Subtract the 2 over, divide the 5 out, y is 3. Again, I write the answer as an ordered pair, because you could graph those two, and that's where they would intersect. Okay? Again, just like the other solutions, if you got out here and they both canceled, and you got 0 equal to 8, not true, that's false, so no solution. You could cancel them both out, and you got 0 equals 0, let's say. That's true. Infinite solutions. Okay, so you get the same result with your solutions in the elimination method also. Let's take a look at some more examples. Okay, they're not always that easy. Sometimes you have to multiply one or both equations. When I look here and I try to add down, I see that I wouldn't cancel out an A or an S. But I do notice that if I had a negative S in either spot, they would cancel, because a positive S minus s is 0. So I chose to multiply the top equation. So that's what I did. And when you do that, you're going to multiply that by every term on that equation. So that's how I got a negative a minus s minus the 101. Okay, you got to multiply all the way across. And now when I add down, you can see my s's cancel. So I get 1.5a equals 64. Solve for a. Divide out the 1.5, you get a is 42. Then stick to 42. I went back to my original first equation. 42 plus s equals 101. Subtract it over. S is 59. 42, 59. When they don't give you, when it's other letters, I usually do it alphabetical. A comes before s, so 42, 59. And then sometimes you got to multiply both equations. Okay? You notice here I can't just multiply 3 to get to 4 or 2 to get to 3. So it's your choice of what you want to cancel, x's or y's. I chose to cancel out the y's. I usually try to cancel out the one that has the smaller numbers, because you can multiply by smaller numbers, it's a little easier. And I know that if I multiply by 3 here, I get 6. If I multiply by negative 2, I get negative 6, so they would cancel. That's what you're trying to do. You got to have different signs here, so if they are the same, one of these will be negative. If it was already plus minus, I'd keep them both positive. Once you do that, now multiply each term by 3. I get 9x plus 6y equals 3. Multiply each term by negative 2. I get negative 8x minus 6y equals 4. Now I can just add them up. I can see that my y's will cancel out here. See ya? I get x plus 0 equals 7. X is 7. I take my original first equation. I plug 7 in for x. Subtract the 21 over. I get 2y equals negative 20. Divide out the 2. Y is negative 10. 7, negative 10 is my solution. Okay? So, always look to see if they'll cancel out right away. Or look to see if you can cancel one of them out by just multiplying one equation. But a lot of times you got to multiply both. Okay? We're going to look at a bunch of examples of all of these, okay, in the next couple of days. And some application. There's a lot of good application of this stuff right here. And we'll take a look at that in class also. Okay? So Get all this here. Bring your questions in the class tomorrow. We'll talk about it tomorrow. Look at some examples. All right, see you then. Bye.